Welcome everyone. It is July 15th, 2013, and this will be my 18th, that is 18th session of Moonscapes. I'm going to open up this session and talk about a little bit about the equipment I'm using. Sometimes I kind of forget to mention what I'm using to let you know what equipment I'm using and eyepieces and such, so we have an idea of what we're working with. Tonight I'm using my 5-inch Maksudov Cassegrain, the shorter tube in measurable length, but a longer focal length because of the folded light path. And I am using my 5mm 305 power eyepiece again tonight because we've got actually fairly good conditions for Connecticut. I was going to try to get out last night, and the sky was beautifully clear, but the seeing conditions, according to my sky clock, predicted very, very poor seeing. And again, if that's surprising to you, we had a very, very cool night. It was a September, October-like night here last night. Crystal clear skies, and you might think, well, that's just a great night to get out. Well, it is, again, as I said before, if you're going to do the faint fuzzies, the galaxies and nebula and things like that. But if you're going after the moon and the planets like we are and looking for fine detail, those fine crystalline nights are not the night to be doing that type of work. That is because under those conditions you have nearly perfect radiational cooling conditions where the Earth releases its heat that is built up the day into that crystal clear sky at night, and it makes your image just boil. So that's why I did not get out last night. I decided to wait until tonight. It is a nice clear night tonight, but the seeing has settled down. That's one nice thing about that clear sky clock predictor. I can pick the location right where I am, and it gives me the sky conditions out at least 36 hours, so I know. Like tomorrow night here, it's going to be partly cloudy, so it would not be a good night. But last night, I knew I was going to have a perfectly clear night tonight, and I was going to have good seeing, so here we are. Again, I've got the 5mm eyepiece. We are centered right now on the crater. Well, they're slightly off center. They're slightly right of center. Down near the bottom is Ptolemaeus. Near the middle of the screen is Alphonse. Alphonse, if you remember, has those 3 dark spots on its crater walls, which makes for interesting configurations when the sun gets in different higher angles. That crater above Alphonse, which is up near 12 o'clock, hang on, I've got to look that up. I can never remember the name of that crater. It's a very difficult crater to pronounce. Arzacchel or Arcazella. I can never quite remember exactly what it is. My computer keeps wanting to do a shutdown from doing an update, and I thought I had done that last night before I shut it down before I went to bed last night, but for some reason, I don't know, it wants to do it again on me here in the middle of my program, so I keep on postponing it until I get through my program here. Then I'll let it go do its thing. We got a nice view here along this. We're a little off the terminator. We're a little bit out into the sunlight, but we got a beautiful view of this area here. We'll move up along. I'll tell you what. Let's first of all move over a little more towards the terminator. And we'll get a look and see what's going on there. That dark mar that's coming near the middle to top is Mar Nubium. There's some interesting features right there, coming into the middle of the screen. Now let's just stop for a second. Again, I've got my atlas for my lunar names and stuff that's off to the side of me here. So I've got look over to the side, and my voice may trail off a little bit, but I want to see what those, see those craters that we're looking at right in the center of the screen now. They've got partially ruined walls, but very curious looking. Let me see if I can get some diameters and names for those. The one that's right near the center of the screen is, let me see, I got that located, Gorecki is the name of that one, and that crater is 35 miles in diameter. And then the one down below it, going towards 5 o'clock, that ruined crater is, let's see, that's Perry. And hang on, there's a small crater inside Perry. I've got to be careful because this computer, okay, yeah. Perry, that's 29 miles in diameter also. That's a really interesting area. And let's, I've got some zoom here. Let's zoom in a little bit and take a little closer look at that area. This is an area you should be interested in when I get done taking some stills. I'll get in here later and maybe take some stills of this area. It's pretty interesting. Okay. I've noticed I got a little dirt spot over right near 9 o'clock, right near the edge of the field. I cleaned this eyepiece today with some very nice new cleaning tissue I found, which is very, very slightly moistened. But I see it smudged a little section, and I didn't see it, and it's showing up very slightly now and then. I'll have to make sure I touch that up for the next time. I'm just enjoying this view. This area here is it's quite fascinating. It's kind of historically important also. Yeah, it's about as close in as I can get on that view. That's a real nice area. That's in the lower section of Mare Nubium. Okay, let's back out a little bit, and we'll zoom up a little bit more. I want to see if I can find, yeah, I think there, okay, yeah, there it is. Well, that's out a little too far. We're starting to see some effects of the edge there. I want to bring this down. See that fairly large crater that's just coming into sunlight? The floor of it is still in deep shadow. Okay, I'm going to get you the name of that crater, and then there's some historical interest to that crater, actually. Well, historical in my lifetime anyway. It's a rather important feature, which I'll give you some information on here in a second. That crater is Bullialdus, and that crater is 37 miles in diameter. Let's zoom in just a little bit on it. Very, very well-formed crater, very, very high walls. The reason I said this crater is interesting historically, if you go into YouTube and look up Ranger 7, that is Ranger 7, Ranger with an R. That's a series of space probes, moon probes, that we launched to the moon in the 60s before the Apollo series got going, when we were trying to study the surface features. I'll get into the 3 different programs we had at that time, but that was the very first one. The spacecraft were loaded with cameras for close-up views of the moon, but they were just aimed at the moon. We picked a spot that we wanted to hit and study, and the cameras were started rolling when the spacecraft got close to the moon, and then they would just take pictures with different focal length lenses all the way down until the spacecraft hit the moon. I see we got a little bit of high puffy cloudiness that kind of built up around us as passing by the moon. I don't think it's going to hurt us too much tonight. But these spacecraft would go down, and they would just keep taking images until they got until they smashed into the surface of the moon, and they would stop taking images. Well, Ranger 7, on YouTube, there's a nice view of single shots taken by Ranger 7, and it's imaging right as it goes over that crater Bullialdus. I believe that's how it's pronounced. And it just goes out of the bottom of the frame as the spacecraft is starting to get fairly close. Initially, it doesn't show up very well, and then the detail really starts to increase as the spacecraft gets closer and closer. And it heads, the spacecraft actually heads, and I'll move down towards it, wrong way. It goes over that crater, headed down, and very near where we were looking at those nice ruined craters. About halfway between those nice ruined craters and our crater Ballialdus, the spacecraft slammed into the moon on that Mars floor there. And the last couple images that it actually took pictures of crater pits that were probably a foot or so across. We also had a series which was called the Lunar Orbiter, where we put the probes in orbit around the moon so they could take selected spots and looking for Apollo landing sites. And we also did the Surveyor program, where we actually landed spacecraft on the moon, where they could take photographs on the surface and dig the surface and check it. And the reason they did this, and I grew up, I'll tell you what, I'm going to back out a little bit, and we'll kind of zoom around the moon as I'm telling you this rest of the story. It's interesting because I grew up when this happened. I was born in 1944, so I remember the 50s real well. Of course, the space race got started in 1957, and shortly after that, we were doing these probes to the moon, and I was hanging on every word. I was, let's see, in 1960. Those probes were launched in 1964. So actually, I was a little bit older by then. I was almost 20 years old then. But I remember back then, you didn't have the live coverage. And when one of these probes was being sent to the moon, you had to wait till the news come on at the top of the hour to get the latest story. And I used to just hang on every word waiting for the latest on the probe and how it was doing. And the Ranger series, here we're getting into the southern highlands here. Look at the detail here. This is really something. There was a huge debate when I went back from the 50s and 60s, when I first got into astronomy, about what the lunar surface was like. And there was actually at that point some very serious questions whether we were going to ever be able to land on the moon. And the thinking was, well, we finally determined that all these nice, look at all these beautiful craters. That's Tycho up near 12 o'clock on top of that nice central peak. There were a lot of scientists very seriously saying that because of all these impacts making these beautiful craters that we're looking at, that it threw up huge amounts of dust. And this dust settled on the moon, and there were some estimates that this dust was up to 1 mile and 2 miles deep, and if we ever landed a spacecraft in it, it was just going to go settle right through the dust and disappear, and we would never be able to land on the moon. And there were those that would say, no, it was just like, there'd be dusty surface, but there'd be a hard ground to land on. And there was a big debate about that for a number of years as I was growing up. So I hung on every word back then about these studies, and that's what those programs were about. The Rangers were taking the first close-up photos, but they took, of course, as I said, they smashed into the moon, and they showed what the surface looked like. We knew it was dusty, but we couldn't tell just how deep. The surveyors, I'm sorry, not the surveyors, but the lunar orbiters, again, took nice photographs, gave some indication what the surface was like, but it wasn't until they actually put the surveyors down when they landed, and they actually touched down. The footpads did not sink in. We got pictures of the craft sitting there, and the footpads were visible, and we were able to dig and test the surface and all. And it was that point, and that was, let's see, I was in the Navy when that series was taken part, so that was like in 1966 and 67 is when we really determined that the moon was going to be safe to land on. So, I mean, right up to just a couple of years before Apollo 11 in 1969, there were some serious questions about what the lunar surface was like. Okay, let's see, we're not zoomed in very far, so let's get a little more zoom here and enjoy this view of Tycho. Look at this view of Tycho. let's see, you can see clearly the terraced walls and that central peak. That central peak is just actually gorgeous. And again, I've talked to you about that before, how that formed. Just much like throwing a rock in a pond where you get that splash and the water separates. And when it rushes back into the center and it hits in the center, you get that secondary splash. And that's exactly what happens here with these central peaks. The moon actually acts like a liquid. It's being hit so hard with such high speed and big objects that it acts almost like a thick liquid, and that's why you get these rebound central peaks. And again, we talked about why they don't all have them, because a lot of things are involved. You know, the speed of the object and the size of it and the angle of entry and all that. There's a lot that comes into play, but it's really interesting how they make those central peaks and what beautiful craters we get out of them. Let me see. Up above, I'm going to check something on my map here before I say too much more, because, yeah, that crater above and to the left of Tycho, if you look at it really, really quick, it almost looks like Clavius. But it's not. It's the crater Maginus. That crater is 99 miles in diameter. But if we continue on up, we're going to run into Clavius, and it should be a real view tonight, because it's going to be very close to the Terminator. And there it is. There it is. It's just coming into view. Let's get it over and a little more centered. I'm using my Skyview Pro mount again. That smaller mount. It's lighter and easier to set up, and I've got kind of a wacky schedule going this week. My wife needs to use the car, and as most of you know if you've listened to my videos, I kind of use my car as my control room for this project. I set the telescope up outside, run the wires inside for the computers and the camera, and I sit in my car and control everything and run the telescope outside. But I'm not going to have the car available to me for the next few nights, so that's kind of why I'm glad it's going to be cloudy tomorrow night. That's why I really wanted to get out here tonight. But anyway, that view of Clavius, that's just amazing. I just want to double check. They're given the sizes that I thought I was, in my mind, I always said it was like 157 miles. It's actually 136 miles in diameter. But that's a huge crater. In fact, in the past, it's actually been called a walled plain. And that kind of gives you the impression that it's not really a crater, that it was formed by some other process. It was it's actually like a small mar, but and I do believe it is a complete crater. It was formed by a very, very huge impact. And then you can see those other impacts that took place after Clavius was formed. You've got the crater right at 12 o'clock in the wall of Clavius. You've got one over there about 7 or 8 o'clock in its wall. And then you've got 4 or 5 smaller ones in the floor of Clavius. And if you just keep going down with higher and higher power, you'll see smaller and smaller crater pits that we can't see in this view. And then there is a very, very well-formed crater. Let me center that up there. I'm not sure the name of that crater. It almost looks like a double for the crater Tycho. It's got a beautiful central peak in it. And I am not sure the name of that crater or its dimensions. That crater is Mortus, M-O-R-E-T-U-S. It's 69 miles in diameter. It's almost dead center in the screen. And it's almost a dead ringer for Tycho. But it's higher up in latitude. It's farther up. Actually, in reality, it's farther down, because we're looking at the south here, pole here. The image is inverted, so we're looking at the south pole of the moon. But that's a dead ringer for Tycho. And boy, you can see the terracing in that walls of that crater and that beautiful central peak. That's a really, really nice formed crater. You know, one thing I have not even checked since I've been on is color. For some reason, I'm getting a blue cast, and I think that's because I'm near the edge of the moon. So let me get away from the edge of the moon, and let me see if I can, yeah, there we go, we got rid of that. That blue is being caused, see, that's where you've got to be careful and not jump to conclusions about color on the moon. That blue was being caused by the image being very near the edge of the field of view. And it actually, for some reason, it confuses the camera, and it threw that false blue color. Now you can see there's not blue going on here, so that was not true blue. But now that we're back away from the edge, I'm going to reset the camera, and we'll see what we've got for color tonight, if there is any. Colors right now is low. It's at around 20%. I'm going to go up, and I don't want to go too high. I'm going to leave it right around 60. We don't see much color there. We might see more when we come down and get into the plain area. I'm trying to look at the time that I'm 21 minutes in. I want to be a little careful of the time here. I like to keep these somewhere around 30 minutes, but I generally end up going a little bit longer than that. I get going and I tend to forget where I am in time, and I lose myself. Let's back out a little bit. Got some fairly nice zoom with this 5mm. Again, this is a series of eyepieces that Orion makes. It's a Stratus eyepiece. But this is another company that makes the same type. This eyepiece is a Hyperion eyepiece. And these are 68-degree field of view eyepieces, and they work really, really well. And as I said, it has a lot to do with the placement of the camera. If you just slap the camera on there and then just, push it all the way down on top of the eyepiece and call it quits and come in and focus up, you're not going to get the best positioning of that camera. It may or may not be in a good position. In fact, you can see that purplish off to the left-hand side. That's actually because the camera is probably tweaked just very slightly off. Now, if I could take the time and go out and fix that, but I'm not going to bother. I'm going to just kind of zoom up a little bit and get rid of as much of that as I can. And that can be fixed by just slightly tweaking the camera until you get a little better seat of its position. But if you got to take your time and position the cameras carefully, or you're going to get false color, and you're not going to get the best position of the camera for camera operation for zooming. Okay, let's go down a little more. I'm going the wrong way. And again, I'm using that Orion Skyview Pro mount. So the acting of this mount is it's slower. It doesn't react as fast as my Atlas mount. Okay, we're going to drop down here. We're back down near Ptolemais. And we'll get on the floor here. I'm just looking for color. I'm not seeing much. I keep on getting that warning for the ones to shut down my computer and restart it. And I keep on postponing it because we're getting close to the end of this anyway. There again, that blue on the edge again, that I believe is suspicious tonight. I think that's being caused by the camera being slightly off. Now this is an interesting view coming right down here. Okay. Okay, let me see. I'm going to get my map before I know where I am, but I want to just double check myself. Yeah, that big crater just coming into view, that big honker, that's Copernicus. But that nicely formed smaller crater dead center is Reinhold. It's got that little crater off of it. Reinhold is 29 miles in diameter, and in that crater, tucked in real close to it, right about at its Reinhold's about 7 o'clock position, is actually called Reinhold B. And that's how they name a lot of these craters on the moon. They'll take one major crater, and if it's got a bunch of small craters around it, they'll call them A, B, C, D, according to their size. If there were another one there, and there might even be that we can find, and it's a little smaller, that would be Reinhold B, and then Reinhold C, and such. Right, let's get down here, and let's check our old friend Copernicus. Remember the other night we looked for that crater chain along the walls of it going up towards Aristophanes, and we were quite successful. I had a good view of that crater chain, and I'm not so sure we're going to be as lucky tonight. Let's see. We can increase the zoom. Looks like we're getting some more clouds again. Boy, Copernicus, look at the terracing in those walls tonight. That is just absolutely beautiful. Okay, Aristophanes is located a little bit different tonight. It's located down near 8 o'clock. So that crater chain, yeah, it's there. It's clearly there. Halfway between Aristophanes, which is down near 7 o'clock on the edge of the field, and then halfway between that and Copernicus, which is the huge crater, beautifully shaped crater, is our chain of small craters. And we can zoom in a little more. And oh yeah, they are showing up really nice tonight. Let me see if I can center that better. I think we got it there. It looks pretty good there. And I have got pretty much full zoom. And boy, that chain of craters is really standing out nice. Doing that on a large screen at a later time is going to be really nice. Notice something else is very interesting. It's showing up very well tonight. Let me get my positioning on my map first. All right. We're looking at Copernicus, and then down, of course, that nice chain of little tiny craters. And Aristophanes is touching the edge of the field down at about the 7 o'clock position. Almost dead center in the screen. Notice what looks like a ghost crater. They call them ghost craters because you can see there is a crater there, but due to lava flow or whatever, a lot of it has been covered up, and it's leaving just a hint of walls and a circular pattern there. And that is the crater's status. It is 42 miles in diameter, so that's a large structure. And it just looks like it was flooded out, and it left the upper part of the walls there. That's a nice view of that. That's a view we haven't had before. I don't remember seeing that well before. It stands out real well tonight. Something else I want to do when we're in this area here tonight. Let's back out a little bit. Yeah, it is there. Our old friend Franz Gurthasin's section of the moon, where he thought the Selenites had built a city. Our friend, the crater Pallas and Murchison, are dead center. And then now, let me just say something about that. Remember we tried looking at that the other night, and there really isn't much there that I can see that he was trying to draw cities out of. But he actually was studying that whole area, and not just the crater Pallas and Murchison himself, but notice over towards 3 o'clock, there's that real dark patch of Mar. That was part of the area that he said was very suspect, and they were even suggesting back in those days that could be vegetation. Of course, we know it's not, but back then they thought it was, and it was connected to this Murchison and Pallas area and the whole selenite situation. I've got a little more zoom. Let's zoom in. But again, this is not a good night to check this area. We're right on the center. We're centered right on Pallas and Murchison. There's no sign of any real structures. There is that one that's to the right of Pallas, which is an elongated mountain range. That could have been suspect. But he was over in the area to the right of that. And I want to go over there a little farther and see if we center it. No, I don't think we're going to get... okay, I don't want it to drift too far on us. We'll lose the whole ball of wax. There we go. No, there's not much going on there. But again, we're a day late and $1 short here. If we really want to check that area seriously, some night we're going to have to catch that when it's right near the terminator and the shadows are very, very long and elongated, and we can really study it close up then. And now I notice I'm 31 minutes in, so I'm going to just take a second here, back out, drop down towards the more northern end of the moon, which we haven't gotten into tonight. Just take a quick look at that before I sign off. As I say, we're using a high power eyepiece, so I don't have a wide field to play with, but there is the Apennine mountain range curved. Look at that. That's beautiful. Really stands out nicely tonight. And we'll come down there is Archimedes. And then we're going to come down. We're actually heading north now, actually. Just off center is the crater Cassini, with that another small crater within its floor. And then there's that extended range of the Apennines going over towards the crater Plato, which is over right in the corner of the field. And of course, standing out almost dead center is the Alpine Valley that cut through the Apennine Mountains. Crater Plato, let's give that a shot more centered and put some power on that and see. One of these nights we get a real good scene. I'm going to have to put a Barlow on this 5mm and really try getting in good. And if we get a night that I know is going to be really good, I'll get the good old heavy duty Atlas mount out, and I'll get my 10-inch Meade going, and we'll get in and get a good look at a couple of these craters. One of the things I'd like to do with this crater is on the floor of it there are a bunch of tiny little craterlets. And it takes real good seeing and high power to see them. And I don't think we stand any chance of that tonight, but we'll zoom in as far as I can. Okay, we're zoomed in about as far as I can go. The scene's kind of coming and going, but that is a very, very interesting crater. As I say, there are little crater pits on the floor, and I think if we get a real good night, I use the 10-inch, this 5mm eyepiece, and use a 2 or 3x Barlow, and we would stand a chance of picking some of those up, but it'll take an exceptional night. That's about it for tonight, folks. I didn't have anything really special planned. I just wanted to get out here. It looked like we were going to have a decent night. We did. And I figured we had a chance to use this 5mm eyepiece, which tends to give us a little closer in look. I like using it, but then I also at times like to be able to use a lower power so we get more colorful views of the moon. Tonight we're not getting much color at all. Color intensity, again, I'm up at 50-60%. If I go up a little more, let's see, do we get anything here in the floor? Nah, it tend to kind of go a little bit brownish, but that's about it. In fact, I've almost gone a little bit too far. It's starting to back it off just a hair. But that's going to be about it. Okay, as I said, I've got a tough schedule. I don't know if I'm going to get another video during this moon cycle. I will try, but if I don't, we'll be back again in the following cycle, and we'll pick up something else to look at and study. So in the meantime, everybody, good health, clear skies, and we'll see you next time around, folks. Take care.